Bismillahirrahmanirrahim. Assalamu alaikum students. Once again, I'm Sadia is with you with another lecture of chemistry, unit number 2, and our today's topic is Rutherford's atomic model. Before starting this atomic model, I'll give you some background knowledge about another atomic theory. Students, it is a series of experiments and theories which leads to discovery of electron, proton, and neutron. Joseph John Thomson was one of those who proposed an atomic model called plum pudding model. And in this model, Thomson concluded that atom is positively charged in which a negative charge occupied a region of space. Plum pudding is a dessert. Here represent uniformly positive charge as pudding and negative charges are represented by plums. Plum pudding model was one of the most accepted model all over the world for understanding the structure of atom. However, several experiments performed by scientists to study the atomic structure showed astonishingly different results. They were contradicting the plum pudding model. This led scientists all over the world to reconsider the structure of atom and started again. In 1911, a British physicist, Ernst Rutherford, who was a student of Thomson, carried out the famous gold foil experiment. Experiment was carried out by Rutherford along with Hans Geiger and Ernst Marsden. This experiment was breakthrough in the field of chemistry to understand the atomic structure in more accurate manner. This is how the setup of experiment looked like. He used a source of alpha particles locked in lead container with a small slit which ensured the alpha particles only come from hole in a straight line. Alpha particles have high energy and heavier than protons. Basically, Rutherford was doing work on plum pudding model. If the atom is just as putting up positively charged particles with the electron embedded it, then the alpha particles should pass straight through it. This is what Rutherford thought. Now let us look what are alpha particles. In nature, there are many elements who are radioactive. Elements whose atomic number is greater than 83 all are radioactive. It means they are unstable and release alpha, beta and gamma etc. particles to stable them. This emission also decomposes them in some other elements. Radioactive elements in these experiments were polonium and radium. From these, Rutherford got alpha particles, and alpha particles are helium nuclei. He bombarded alpha particles on gold foil. He used a thin gold foil of about 0.004 cm of thickness. Why did he choose gold foil? Well, a thin gold foil was estimated to contain approximately 1000 atoms. Lesser the atoms, more easy the experiment would be. He used a circular band as fluorescent screen which helps to detect the radiation. It means whenever alpha particles will hit the screen, it will glow. The alpha particles are emitted from the box and directly hit the gold foil. It was expected that alpha particles should go straight through the gold foil and hit the screen, as the mass of alpha particles is heavier than protons. Only a small deviation would be acceptable in this case. But is this what he observed? He is surprised to get opposite result. He found that most of the particles passed straight through gold foil and hit the screen. However, small particles get deflected through small angle. Few alpha particles rebound. It means many particles pass through. Some particles change their path and few rebounds are reflected back. So the observation conclude that the plum pudding model was not really perfect. Now Rutherford put forward a new hypothesis or conclusions. Let us have a look at his conclusions. He found that most of the alpha particles pass straight through undeflected, whereas some alpha particles deflected by small angle. Few of alpha particles are rebounded. Let us understand with an example of cotton ball. Cotton ball is having a hard, dense sphere or center that can resist a bullet. Now what will happen when we shoot many bullets from cotton ball? Most of the bullets pass straight through the ball. If a bullet hit the edge of the center, the bullet will slightly change the angle and get deviated. And size of the center is small, so some bullets will deviate it. But what happens if the bullet hit the center? It will bounce back because central dense part is too hard. It is similar to what Rutherford thought about atom. He concluded that most of the space of an atom is empty, that alpha particles can easily pass through them. Secondly, he concluded that most of the positive charge is occupied in a small, dense space. Few alpha particles get deviated. It means there is a possibility that they hit the edge of the center. As alpha particles and center both are positive, so center will repel the alpha particles. A small number of alpha particles rebounds, so there is a possibility that they hit the center of the atom. And center is small because only few particles bounce back. If the center would be big, many alpha particles would be bounced back. In a gold foil, many alpha particles pass straight through it. Few get deflected and very few bounce back. On the basis of this result, Rutherford gave an atomic theory. Let's have a look on hypothesis by Rutherford. There is a positively charged center in an atom called nucleus, which contain nearly all the mass of atom. Electrons revolve around the nucleus in circular paths. The size of the nucleus is very small as compared to the size of atom. Theoretically, there were many defects in this model, which I will discuss in next lecture. Thank you so much, students.